Hello and welcome to our sixth maths lesson within the bridging units and the second part of the Latour by Numbers project. So today's lesson objectives are as follows: to understand and use the formula for calculating speed and to understand and use a distance time graph. So we're on to the next stage of this two-part lesson. Stage 2, speed, distance, time, the green jersey best sprinter. And to be a good sprinter, it's all about speed, isn't it? But how do you calculate speed? Well, the rule for speed equals distance divided by time. And we can represent this in something called a formula triangle. Now, here's the first one on the screen now. A formula triangle represents a rule that has three parts. Here you can see S for speed equals distance for D over time for T. So distance over time is the same as distance divided by time. That's how the formula triangle works. Let's change it up slightly. Let's say we wanted to find time instead of speed. Well, time there, you can see circled, is distance over speed, d over s. So that's distance divided by speed. But if I wanted to find distance, well then that would be s times t, speed times time, as you can see there in the formula triangle. So let's have a look at some examples. Example 1. 150 kilometers traveled in 3 hours, find the average speed. So speed equals distance over time. So we're given a distance d of 150 and a time t of 3 hours. So speed equals distance divided by time. So that's 150 divided by 3, which equals 50 kilometers per hour. Example 2. 240 kilometers traveled at 60 kilometers per hour. How long would it take? So how long would it take? We're asked for time. So we have a distance of 240 and we have a speed of 60. So time is distance divided by speed. So that's 240 divided by 60. So that is 4 hours. And the third example. How far will you go for 1.5 hours traveling at 50 kilometers per hour? Well, the speed here is 50. The time is 1.5. Distance is speed times time. So we will do 50 times 1.5, which equals 75 kilometers. And notice there, it said in the question 1.5 hours. And I've converted that to a decimal to make it 1.5 because 0.5 is half. So now we've gone through those examples, it's your turn. Have a go at these 3 exercises working out either the speed, distance or time. Okay, here are the answers to stage 2. Answers are on the screen. Mark your work and see how well you got on. Okay, we're now on to stage 3, the yellow jersey, leader of the tour stage, and this is about distance time graphs. Distance time graphs are a helpful way of representing a journey, or in the case of cycling, a race stage. Now, if you look carefully at the graph, you'll notice on the x-axis along the bottom is time, and along the y-axis going up is distance. Look particularly at the red line. This represents a journey. Part A, the diagonal line going up, is when a person has moved away from a fixed point and is going at a steady speed. Part B, when the line becomes horizontal, flat, that's when the person stood still. Then part C, where the line is diagonal but going downwards, that's when the person is returning to the start, again at a steady speed. Imagine you're in the park and you ran to a certain point, stood still for a few seconds, and then ran back to where you started. That's what this would be like. So here's an example of a distance time graph, and I'm going to show some questions linked to this graph and the answers as we go through. So first of all, what time did we arrive at Bradford? Well, if you look at where the line reaches the distance of Bradford, look at the time and think, right, what is each square worth? There's 4 squares between 10 and 11, so 1 square must be worth 15 minutes. It's gone across 2 squares, so that's 30 minutes, so the answer is 10:30. What's the distance from Leeds to Huddersfield? Well, we'll look on the y-axis there. From Leeds up to Huddersfield, it's in between 40 and 50, so it must be 45 kilometres. How long did we stay at Huddersfield? Well, that's where we're looking for that horizontal line to mean that the person is stationary. That's moved across 2 squares. That must be 30 minutes in total. What was the average speed to get from Leeds to Huddersfield? Now go back to stage 3. Remember, stage 2. Sorry. Remember, speed is distance divided by time. So the distance from Leeds to Huddersfield is 45 kilometres. The time it takes to get from Leeds to Huddersfield is between 10 and 11. So that is 1 hour. So the speed is going to be distance divided by time. 45 divided by 1 hour. So it's 45 kilometres per hour. Final question. What's the average speed of the return journey? Now remember, the return journey is when the line has a negative gradient or is going down. This looks like it goes from 45 kilometers back to 0, and the time is between 2 squares across. That must be half an hour. So it's 45 kilometers in half an hour. So what would that be in a full hour? Because remember, speed is measured in kilometers per hour. So 45 kilometers in half an hour. What would it be in a full hour? It's going to be 90 kilometers per hour. Okay, there is a question for you to try at stage 4. See if you can work out the journey from the description. So here is your next task, distance time graph. If you're able to, print off this slide so that you have the graph that you can work from. If not, draw out the axes and the graph as you can see it on the screen. Use equal spacings for the time and distance as your x and y axis. Okay, here's Mr. Pearson's bike ride. Mr. Pearson sets off on his bike at an average speed of 8 miles per hour. After 1 hour, he reaches Bradford and stops for a 36 minutes rest. He then sets off again, this time at a quicker pace, and reaches Halifax at 10 a.m. With not much time to get home for his breakfast, he stops for 12 minutes before taking 48 minutes to ride home to Leeds again. Can you draw his journey on this graph? Okay, here is the answer. Look carefully at the diagonal lines and the horizontal lines on the graph. Is yours the same? Have you managed to get it correct? Okay, so our objectives for today were to understand and use the formula for calculating speed and to understand and use a distance time graph. So to reflect on this lesson, and you can use your Bridging Activities booklet to write this reflection, 2 questions to think about. How do you calculate speed? What's the formula to remember? And what are the features of a distance time graph? Use these questions and complete your reflection in